look at factoring of the polynomials. Now, this is a lot of mental gymnastics where you have to take a look at things and see what's going on. So, the best bet that I can do for you is just going over the examples and look at how to go first. So, when we're looking at this, I want to go and see if there's something in common. So if I'm looking at this one, do you see something in common throughout them? And it should be that 3. If I factor 3 out, what's left? Well, you got x squared plus 2x minus 1. Now we can take a look and see, can I factor the rest of it?
I apologize for the interruption. Attention all seniors. Seniors that have Mrs. Lund as your ramp-up advisor, please go to the small computer lab at this time. For 5th hour, seniors who have Mrs. Johnson as ramp-up advisor, you will go to the small computer lab, and for instance, if you have also go to the small computer lab. I will not be announcing this, or an example, please go to your designated area at that time.
So, now I need to figure out what's left. I've got the 3. We know that this is x. We know that this is x. You've got that chart that identifies what the signs are, right? You should still have that written down in your notes and in your little book. So, this is negative. This has to be positive. So this will be plus, this will be minus. So the question now comes down to, is it possible for us to go through and get to the 2? Is it possible? And we'll look at this and we'll sit there and look at boiling it out in our heads, that it's not. There's nothing else that can be done. So, can I go any further with this? The answer turns out to be absolutely not. I'm stuck. I can't go any further. Because there's really no way that I can have a negative 1 added and a positive 1 added to get to that. It's not going to happen. So, there are times when you are going to have to recognize you cannot go any further than that. So, this turns out to be the answer. What about B? When I look at B, is there anything that is in common between both of those? First offhand, do they each have an x? Okay, so I got an x in common. Next I want to see, is there any value that I could divide out of both of them? Are they both even numbers? Yeah, 4 is even and 10 is even, so I can factor out a 2. Now they both have to be negative, and I really don't like keeping negatives in there if I can, so I'm going to factor out this thing as a negative 2. So then the question is, what's left? Okay. Well, I got x cubed here. I took away 1x. How many x's would be left? 2. So that would be x squared. When I pull this 2 out of here, now remind you, we're dividing. So what's negative 4 divided by negative 2? 2. What is negative 2 divided by negative 10? But it's got to be a positive. I pull an x out, there was 1x, so that means I'm done. You guys remember that thing called the distributive property? Does this kind of look like the distributive property when I look at the answer? So if I were to go and take this and multiply it by that, what would I get? Well, what's negative 2 times 2? Negative 4. X times x squared, x cubed. What happens if I take this and multiply it over here? Negative 2 times 5 is negative 10. X, there wasn't one, so it's here. When I use the distributive property, these two should be exactly the same. Are they exactly the same? That's our check. That's what we want to do to make sure that we've got it right. Any questions on either one of those? Ones that look like A are usually going to be the trickier ones simply because you have to figure out whether or not there's something else that can be divided out of it. More often than not, but we just had it on here this time just so that you could see that it does happen. So, this little thing is kind of handy. What I'm going to do is I'm just going to let you guys get this copy down. There are some things that I want to talk about here so that you can kind of see the pattern. I realize it looks like a whole jumble of gobbledygook. If I go and take a look at these other two that are down here, these are the ones that you really want to go and take a look at to see if they fit this pattern. Difference of two squares. Something squared minus something else squared. Now, these can be variables. Okay? As long as they're variables to an even number, it still counts as a square. And then your perfect squares, like 4, 9, 16, 25, 36, so on and so forth. Those are what they work out to be. So, if I look at something like this, x squared minus 9 squared, I recognize that as, hey, this is a difference of two squares. This gets just broken up, x and an x, because I got two of them, one here, one there. What's the square root of 9? 3, because 3 squared is equal to 9. So one's a plus 3, one's a minus 3. Now, the perfect square trinomial, what they've got here, this is kind of a sneaky one, but there's always a pattern to it. If I take a look at here, 8 and 16 are related, right? 9 and 6 are kind of related too. How are they related to each other? What's the square root of 16? Well, that's 4. 2 4s give me an 8. What's the square root of 9? 3. 2 3s get us a 6. If it's positive, positive. If it's negative, negative. So if you can recognize that that pattern is there, you've got it. Up here, this is simply, doing what we've done in the past. How do I take a look at the factors to get that term? U and V are always going to be multiplied to get the last term, and they're always going to be added to get to the middle term. And that chart that I gave you for identifying how things factor out, that'll be kind of on the helpful side so you know which ones go where. So you know if it's an addition or a subtraction. So, let's take a look at this. I want to factor this. Now, yes, are 25 and 10 related? Sort of, kind of. There's 5s in there, right? So if I look at this and I say, what's the square root of 25? And it is 5. So it should fit one of these patterns because there's 3 of them here. Looks like it's going to fit this perfect square trinomial pattern. So it's a minus and a plus, so I know that it's going to have to factor out as x minus x minus, 5 and 5, right? If you want to go and check it, do the FOIL. Take our first ones, multiply them together. What's x times x? X squared. Outside ones, x and this. X times negative 5 is minus 5x. This inside ones get multiplied minus 5x. These two, the last ones in the parentheses, multiply together and I get plus 25. So if I add like terms, I get x squared negative 5x, and negative 5x is minus 10x plus 25. What does the answer look like? The answer looks like this: x minus 5 squared. Once you begin to see how to use the factoring things that you just wrote down, you'll have a better understanding of where you're going with this. So now, I've got a question for you on B. Is there anything in common that can be factored out? Not really. And if I look at this looks flat out ugly, doesn't it? I got 4s and 9s and 12. I got m squared and n squared. We haven't seen anything like that before. Don't focus on what the numbers look like. Focus on the things that you see. If I take a look at the pattern, this says a squared, that says b squared. Oh, hold it a second. Is 4 a perfect square? Is 9 a perfect square? Are the variables themselves squared? Okay. So it kind of looks like it's going to follow this pattern right here, perfect square trinomial. The only thing that's kind of missing here is that 12. Well, my question for you, what's the square root of 4? 2. Square root of 9? 3. What's 2 times 3? 6. Double it. The answer is yes. So that means that this should factor out as follows. Okay? So that'd be a 2m and a 2m. This should be 3m. 3m. And this should be plus, and that should be plus. So let's check it and make sure that we've got it right. So another way of thinking about this is each thing in this first parenthesis needs to get multiplied by each thing in this parenthesis. So I can say, okay, hey, these two got to get multiplied together first. What's 4m times 4m? 4m squared. What's 2m times 3m? 2 times 3 is 6. M and n just give me m and n. Plain or peanut. So those two have to get multiplied together. Again, I get 6 and an m and an n. These two have to get multiplied together, so I get plus 9n squared. Do I have any like terms? Yep, right there. 4 m squared plus 6 and 6 is 12 mn plus 9n squared. So the answer for this one should look like this: 2m plus 3n squared. Now remember, the squared part means that there's just two of these things multiplied together, which is what we want. It's a bit of a tedious process sometimes, but if you see the patterns, you can use them. It makes life a lot easier. Questions on either one of these two that you want to know? Okay, yep. take a look at this. These are generally the simplest ones there is. Why? Because all you got to do is identify whether you got perfect squares or not. Can I take the square root of 49? What do I get? 7. Difference of two squares. X plus, x minus, 7, 7. That's it. Now, we'll check just to make sure that I did it right. X times x gives me x squared. X times negative 7 gives me minus 7x. 7 times x gives me a plus 7. 7 positive times 7 negative gives me negative 49. So I got like terms here and here. But if I look at that, if I got a negative 7x and a positive 7x and I add them together, do I have any x's left? The answer is no. So that's x squared minus 49. Now, because these signs are different, it's simply just going to be x plus 7, x minus 7. That's how the answer has to look. There's not going to be any parentheses scripting. Make sense? Yes? No? Maybe so? So, one more. This property bothers a lot of people simply because of that or in there. It says if a times b is equal to 0, then a is equal to 0 or b is equal to 0. Now, when we go through and use this, we actually say that and assume that both of them are equal to 0. That a is equal to 0, we solve. B is equal to 0, we solve. Now, this idea is what we need to use in order to solve these equations by graphing. It's a handy little thing. So, give you some time here. So, we want to get down to where we can solve these. And the thing that we really want to, and are interested in is where is this equal to 0? Because if we can figure out where it's equal to 0, it doesn't matter what type of quadratic equation that we've got, we can figure it out. So, what I look at here is, okay, we got a factor. So we got this, got that, and it's going to be equal to 0. You can't go and drop off the 0. So, I look at this and I see that the x is all by its lonesome. So that's going to be an x and that's going to be an x. What are the signs? Well, if you take a look at that chart that you've got, you know that one is going to have to be positive and the other one is going to have to be negative. So now, we take a look at the 10. The easiest way of dealing with this are what are the factors of 10? 1 and 10, 2 and 5. And I ask myself the question, is there any way that I can use 1 and 10 to get to a 3 through addition or subtraction? Not that I can think of. I can make an 11 or a 9, but I can't do anything else. Can I use 2 and 5 with addition or subtraction to get to a 3? And the answer would be yes. If I have 5 minus 2, correct? Now, I want my 3 to be positive. So that means 5 has got to be positive and 2 has got to be negative. Now, always check. Make sure that you got it right. X times x is x squared. X times negative 2 minus 2. 5 times x plus 5x. 5 times negative 2, negative 10. Still equal to 0. So if I add like terms here and here, I get x squared plus 3x minus 10 is equal to 0. So did I get it factored correct? And the answer is yes. Now I'm not done. Because I'm supposed to solve this, I need to know what the values of x are that make this work. So, using that last rule that we had, either x plus 5 is equal to 0 or x minus 2 is equal to 0. Well, those are easy to solve, aren't they? Subtract 5, x is equal to negative 5. Well, it's kind of obvious. If I've got x plus 5 here, wouldn't x have to be negative 5 in order for it to go to a 0? Over here, I would have to add 2, I would have to add 2, so x is equal to 2. Well, that would make sense, because if I take 2x minus 2, 2 minus 2, that's 0. So, when we are doing the problem with this and they want us to solve, these are the answers down here. X minus 5, or x is equal to negative 5, and x is equal to 2. Those are the two possible answers for this. Yes, sir. Generally, you just write down what are the solutions. Negative 5, comma 2, you'll see it written like that sometimes. Or you'll see x is equal to 5, x is equal to 2. Either one is sufficient. Just as long as you are identifying what they are. Any other questions? So, what I want you to do is I'm going to give you a few minutes and I want you to factor this one. Right. Now I'm going to take a look at this. The first thing is there anything that I can factor out that's common? Well, I got a 12, a 4, and an 8. I know 4 goes into all of these, so I am going to factor out a 4 to begin with. So I'm going to factor out 4. What's left? Well, when I take 4 and divide out from 12, I am left with a 3 and an x squared. 4 coming out of 4, well, that just leaves me with 1x. So I can put down just a plain old x. 4 out of 8 is 2. It's a plus. So, next question is there anything else that I can factor out of this thing? Well, the only real way to take a look at that is to take 3 and 2, multiply them together, so I get 6. So my factors of 1 and 6, 2 and 3. Now, is there any way that I can use any of those numbers to get to a 1? And the answer would be yes. 2 and 3, I could subtract them. But in order for them to subtract, the signs would have to be what? The same or different. They would have to be different. So that means this thing would have to factor as a plus and a minus. So this factors as plus and plus, doesn't it? Yeah, that's why that little chart is handy. So that means that we cannot go any further than this. So you get 4, 3x cubed plus x plus 2. That's all the further you can go. Questions? I will tell you this, generally speaking, you can go a lot farther with it. It's just that for right now, they're just wanting you to identify what's in common. So, I'm going to give you a minute or so and let you do this. So, is there anything that appears to be in common? Well, I got a 20 and a 5, both of which are divisible by 5. So, I'm going to pull out just the 5. I also see that there's 2 x's that are in because I got 3 here and 2 there, so I'm going to pull out an x squared. So what would I be left with? Well, here I would be left with a minus 4x plus 1. If you do the distributive property, 5 times negative 4 is negative 20. X squared times x is x cubed. 5x squared times 1 gives you that. Now, there is also another possible solution. What would happen if I would have factored out a negative 5x squared? I would have been left with 4x minus 1. Which one is correct? Depends upon your perspective. That's just the way it is. So, here we go. Give you a few minutes here and let you try this one. Is there anything in common between anything? No. That plain old x squared, I got a 12 and I got a 36. But as I look at that 12 and that 36, they seem to be related to each other, right? So I got to sit there and I look at it. 36 is a perfect square. Ooh, what's the square root of 36? 6. What's 6 plus 6? 12. So I know exactly what this one's going to be. This is going to be x plus 6 squared. Is this correct? Now, mind you, you could write it out as x plus 6, FOIL it out and see if that's actually the case. And it is. So, let's try another one. Give you a few minutes and let you play with this one. I see that I got a 9 out in front and I got a 25. Those perfect squares should stand out like a beacon in the night. Okay? Yes, a magnesium flare, most definitely. What's the perfect square of 9? 3. 25 is 5. So I know that I should look at something along these lines. 3x plus 5y squared. Does that make sense? Well, what's the square root of 9 is 3. The square root of 25 is 5. What's 3 times 5? 15. What's 15 times 2? 30. Like I said, generally you'll factor it out and you'll end up seeing it like this. But the answer more appropriately is written in this form. So, give that one a shot, see what you come up with. Now, I'm kind of hoping you looked at this one and go sit. This one was drop dead simple. One has got some really weird characteristics in that it's a perfect square, it's a perfect cube, it's almost. So, this is the difference of squares because 1 squared is still 1. We got a subtraction in there, x plus 1, x minus 1. Always a good one to be able to see. So, we've only got 2 minutes left, so I'm going to walk through this one real quick so that you can see what's going on if you want to do that as I'm going through, by all means. So, I look at this, I know what's going to factor out as x plus something and x minus something equal to 0. I got to get a difference of 10, so I got to find values that when I multiply, that would add up factors of 21. So 21 would be 1 and 21, 3 and 7, and I see that I made a mistake. That's addition there. So both of these should be what? Both of them should be negative. Well, that's easy enough. Then that means the signs are the same. One is 3, one is 7. So x minus 3 is equal to 0. X minus 7 is equal to 0. X is equal to 3. X is equal to 7.